chickens yet. So I'm going to build a chicken pen for my new chickens. Exciting. Okay, so I'm going to maximize what I have, and I'm going to use the back fence to save myself, buying extra chicken wire. Currently in my shed, in case you didn't know, I have 17 meters of chicken wire. Okay, I want to maximize the area of my chicken, space running around. So I need to use optimization.
Make it a circle. Make it diagonal.
I'm going to make it a rectangle.
Slide down into the ground so that
Key tip for real life questions, first draw a diagram, okay? All right. So in a rectangle, how do you normally label the sides of a rectangle?
length and width.
So we have our length, we have our width. All right. What do we know about a rectangle?
The area is equal to width times length.
Perfect. What else do we know about a rectangle?
The perimeter is equal to 2L plus 2W, but seeing as you already have 1L, it will be 2L plus.
So the total fence area is W plus L plus W. I'm not counting this length because I'm not using it for wire. Okay? So the second tip, after you've drawn a diagram, use rules that you know. Okay? Right, so now, is there anything else in the question that we could use? So what is the 17? Is any of the letters equal to 17? The P. Okay, so we have 17 is equal to 2W plus L. Okay, so we're getting closer. We want to find the maximum area, so we want to find capital A. Is there anything else we could do? Now, we've kind of established what we know. We've drawn a diagram. We want to, because we know it's an optimization problem, we want to find that stationary point. But how? Any thoughts?
Could you maybe make a graph? Oh, I don't know.
Here's a tip. We want an equation that only has two variables.
Or could you go length is equal to 2 width minus 17?
Perfect. So the thing we're trying to maximize is the A. The A equation has three variables, so we want to eliminate one of the variables. So we're going to get L by itself. And then we're going to do, remember, simultaneous equations. So hopefully you've seen this notation before. Sub equation 1 into equation 2. Brackets, sorry. Is that better? I do have terrible writing sometimes. Feel free to correct me. Okay, does that make sense? So now I've got the thing I want to optimize, and it has one variable, so it's kind of like an XY equation now. Does that make sense? So I want to find the stationary points of this. Yes. First expand the brackets, perfect. So now we have 17W minus 2W squared. I'm finding the rate of change of dA dW. So that's 17 minus 4W. And we want this equal to what? 0, because we want the stationary point, or the max min. Okay, and now we rearrange. So this is the max min. So we've got 17 equals 4W, so I brought this over to the other side. 17 over 4 is the width. Okay, so that's the width for the max or min for the chicken pen. That's a rectangle. So we could do this table again. Here's another way to find if it's a max or min. Are you ready? Everyone know what this is?
Double derivative.
The double derivative. What's the double derivative? -4. This tells us it is a maximum. If your double derivative is negative, it's a maximum. Okay, so now we know it's a maximum. We can use the width we found in the original equation, just like the rugby question, to find the maximum. So we're subbing it into here. I'll rewrite it in case I went too quickly. So I'm subbing in, sub in W equals 4.25. Okay, so our maximum, my maximum area meters squared is 36.125. I don't know what the legal area for a chicken is, but hopefully that's enough squared.